Today we're going to be talking about two topics that are going to be used in the next assignment. So I hope you look at this over and certainly ask any questions if things are unclear. We'll be doing a little bit more in recitations as well. This first topic I want to talk about is how to add throws into your own code. All right, so we have done this try and catch in the context of reading opening files, and we will get back to opening files shortly. The question is, where do these exceptions come from? So we want to see how your own code can create these exceptions and how you can use that to sort of help handle errors situations in your own code. There's also in Java something called checked and unchecked exceptions, and I want to show you the difference between those. So a few lectures ago, we were trying to open files and read from them, and there was this place where we took a file object that came from a file name and tried to open a scanner on it. And if that failed, basically, this code here throws a file not found exception, and we have to basically put a try catch around this statement. We're not allowed to just ignore it and hope it doesn't happen. And it may mean that you go back and ask for a different file name. It may mean you just say there's some error and try to just stop the program somewhat gracefully, but you have an option of doing something with that error. So in Java, again, there's something called checked exceptions and unchecked exceptions. If it's a checked exception, you have to put a try catch around it, or indicate that the method that happens in is going to throw that exception and have other code handle it. Others are unchecked, and the try catch is optional, and we've seen this in action, at least on Piazza during homework. So for example, if you have a loop that goes too far and you ask for an index that's not in the allowable range of values for that array, an illegal index or an index out of bounds or index out of range exception is thrown, and your program crashes, right? And notice, just by accessing an element of array with square brackets and some number, you were not forced to add a try catch around it. In other words, you're allowed to fail. Now the reason for this is that checked exceptions are things that the program basically can't really predict, but you can recover from. So asking for a file name that's wrong, you can basically go back and try again. It's nothing to do with like the internal logic of the program that is wrong. If you're asking for a wrong index, an index out of bounds, out of range, then there's some larger problem. Like, why are you asking for that, right? Your loop is wrong, the code itself is wrong, there's some logic error somewhere, and so it's sort of up to you to manage those errors, figure them out yourself. You can try catch it, but you shouldn't do that to fix underlying issues with your code, right? That's an important point. You should actually figure out why your program is throwing these errors and go ahead and fix it. So there are these lists of sort of common exceptions. Array index out of bounds exception is one you'll probably see. We haven't had a chance to do this yet, but there are cases where you could basically not initialize, not get an actual object assigned to an object type, and so it's a null. It's a null reference, and you try to use that, and you get that null pointer exception here. We haven't really run into these other ones so much. Checked exceptions are things like this file not found exception. And again, these other ones are ones that we may run into, but they're not quite as common. That file not found is the big one that we'll see in this course. So you don't have to know all those, but at some point, you're going to be running into them, and so you should at least be willing to Google them or something like that if you see it and try to figure out what exactly it's trying to tell you. So again, where do these exceptions come from? Well, at some point someone wrote some code and said, hey, something's wrong here, and I want to create an exception. So we can throw the keyword throw a new exception object. And so it's important to remember that this is an object. It's not a primitive like one. You don't say throw the index out of bounds thing. You're basically calling for a new index out of bounds object by calling this constructor here, right? So we're calling a constructor, creating this index out of bounds exception object, and throwing it. When you throw it, Java sees if there is a try catch that's trying to catch one of these index out of bounds exceptions or something more general like just exception, and it will jump to there if that's true, and if it's not caught, it'll just stop the program and show that exception anyway. So, we've been working on a circle class, right? And again, there's sort of two parts here, right? One is the data the class stores, and then there are the methods of the class, which include some common elements, which we basically always have in a class. A constructor that sets the internal values to some meaningful and legal state, and then methods that work on the class. So those are often some setters and getters that get values out, setters that set values, and maybe some other methods that just sort of work in general on instances of the class. So here at one point we had some code that said like, hey, if this radius that we're trying to set is negative, then clamp it to 0, right? And we sort of admitted at that point that it's sort of I won't say a hack, but it's a decision that somehow says, hey, we're expecting that if you have a negative value that you really want a 0 radius circle, and we're just going to set it there for you. But that's not always true. Sometimes you want to report that there's some sort of negative radius happening, and we can do that with a throw mechanism. So in here, I'm just going to replace this thing that sets the radius to 0 to a throw. And what am I throwing? I am throwing a new exception object. And there's some choice of what you should throw, right? It's not an index error, since radius is not an index. So the sort of general thing that if you are passing in wrong values to a method, I can say it's an illegal argument, exception. So remember, this is what we call the parameter of the method, and when you call it, that's the argument that's to the method call. So here it's saying, hey, what you sent, the argument, was illegal, and since this is an object, I need to construct it, so I use the parentheses. And so anyway, there's some fussy syntax here, right? Now, I can test this we make a new circle, and here we're setting the radius to 2. If I make that -2 and try to run this, I get just a plain old error, illegal argument exception at circle, and it tells you where this happened, both where it was called from here and where the actual exception was thrown. Now I can create a little more detail here. This object can be constructed with a string message. Cannot have a negative radius circle. And when I run it now, that message gets displayed down here. Now again, I'm not actually catching this. I could have a try catch around here, and then try to do something else based on this negative value, depending on what I think should happen. But I'm not going to do that now. Okay, so really, it's not that hard, except that I'd say the syntax is a little bit weird in the sense that this throw feels a little uncomfortable. Like, why not just throw this exception string or something like that? But it really is an object, and that's because it holds additional data, for example, where the error happened and stuff like that. So you have to just remember the pattern of this, right? And it's certainly okay to look at some existing code to remind yourself of this pattern. Throw, we need to make a new object, so we use the new keyword. This is the name of the type, the class of this exception, illegal argument exception, and we're constructing it. So we have either a default constructor with no arguments, or we have a string value in here that says some message about what happened. Okay, so again, there's sort of a choice in your code. Like, it's very robust, this way of doing it, but then to actually do something about it, you have to start throwing, try and catches around all these set radius, and you might decide that's sort of an awkward way to handle it, and it all depends in some ways what you want to do to fix it at the end. So we will be using these throws a little bit more, and just, you know, they have a place, and hopefully in assignment you'll see how they have some value. Okay, so we're going to stop this little segment of the video and continue on with the next topic.